Hey guys, and welcome to section 3, where we're going to be working with cost functions and optimizers. So in this video, we're going to be looking at cost functions, which are sometimes described as loss functions. So if you hear, which are sometimes described as loss functions, so if you hear cost function or loss function, just use them interchangeably, and they're used throughout the deep learning community to mean the same thing. So we briefly spoke about cost functions or loss functions as a way to tell our network how right or wrong we are. And often in the real world, this may come from a teacher or some kind of oracle, which tells you how well you are doing. Okay. And this is a very strong learning paradigm that's used kind of throughout the world in nature and also in our world. And we kind of adopt a mathematical adaptation of it into deep learning. So the two main loss functions are mean square error, which we're going to talk about next, and also binary cross entropy, which we'll also talk about in this video. But there are a whole host of other loss functions or cost functions. So I do encourage you to kind of read around and see which other ones are out there, because certain ones might be more suitable to your application. So what is mean square error? So mean square error is just the average of your squared errors. And essentially this can be seen as a line of best fit. So if you look at the graph here, if you look at my mouse, you can see here we're trying to fit a line. So imagine fxi is the line, okay, just ax plus b. And what we're going to do is we're going to work out the error. We're going to quantify the error of this line by just summing up the square of these distances, okay? And that just tells us how right or wrong we are. So when you do your line of best fit, you try and a line which minimizes the distance between these points. Okay, and that's all we're doing here. And this is just a mathematical way of implementing that. And then we just take the average. So mean square error is good when you're doing things like linear regression or you have continuous outputs. So pros and cons, it's smooth and convex. Now you might not know what convexity is, but it basically means that one global minimum. And that's very good from a mathematical point of view. Easy to understand and analytically tractable. I'm sure you guys all understood kind of what I was talking about from that previous slide. But the issue is it's sensitive to outliers in the data. You imagine you've got a few outliers that are really large, and that will skew the line considerably because we're taking the square. So if we wanted to do classification, we have this loss function called binary cross entropy, and we have ground truth labels y, which could be a 0 or a 1, and we're also issuing predictions fxi, which is a 0 or a 1. And if you look at the function, it all makes sense. Let's imagine that we get the correct prediction. So this is a 0 or a 1. Okay, so imagine this is 0. 0 times log 1 is 0. 1 minus 0 times log of 1 is also 0, so no cost there. And similarly, if they're exactly the same, then you also get a 0 cost. If they're different, what you'll end up doing is you'll either have 1 times log 0, which is negative infinity, times the minus here gives you a big loss or a big cost, and the same works out if you have 0 or a 1 in this side. So binary cross entropy is the one we'll normally use, and there's the one we used in the previous video, but we did it for several labels. Okay, but just have it in your head that this is how binary cross entropy works. It's just this loss function. So it gives appropriate errors for classification. So you can't really do classification with regression. It becomes very hard to try and use multiple variables. So it does work better for other loss functions and is the standard loss function that you'll use for classification. It's also statistically principled, which we didn't really talk about because you have to understand things like information theory and entropy, which we don't have much time to go into now. But I do encourage you to kind of read around the area if you want to.